All right, guys, this is our lesson on the chain rule. So we are going to be using the chain rule when we want to take the derivative of a composite function. So you've seen composite functions in your previous classes. This is anything that has like an f of g of x, a function inside a function. So some examples of what composite functions would be is if f of x was equal to x to the seventh, g of x was equal to 3x squared plus 5, then you would take f of g of x would be where you take g of x and plug it in for x in the f equation. So you end up with 3x squared plus 5 all raised to the seventh power. So that is what a composite function looks like. Got a couple more examples here where you plug x cubed into sine x to get sine of x cubed. And then this one where you plug cosine x into x and you get cosine x cubed, which we normally write as cosine cubed of x. All right, so things you already know how to take the derivative of are plane functions. So something like y equals 5x to the seventh, you just use the power rule there. F of x equals sine x, you would do the derivative that you know how to do, and y equals cosine x, same thing. All right, so today we want to be able to take the derivative of composite functions. And so we'll go through the process of how that works. All right, so in problems such as this, it says which you learned how to differentiate last year, which is not true. So which we're learning how to differentiate today. The chain rule can be written this way. All right, I don't like the way this is written out because it assumes the power rule. All right, that the power rule is always going to happen. You multiply by n, you subtract one from the exponent. So I'm going to just kind of skip over that part, and we're going to write it the way that our Larson textbook writes it. So the derivative with respect to x of f of g of x is equal to, so you start with the outside function, you do the derivative of the outside, you keep the inside part the same, and then you multiply by the derivative of the inside. So derivative of the outside function first, keep the inside the same, multiply by the derivative of the inside. That's the chain rule. All right, and that's what's happening up here. The outside function is the power. So you start with the power rule, multiply by n, keep the inside part the same, subtract one from the exponent, and then this is the chain rule part. Du over dx is the same thing as g prime. All right, this is the same thing as u prime on that one, just written in Leibniz's notation rather than Lagrange's notation. All right, so let's practice doing some of these. So why is the chain rule important? There are many composite functions that we need to be able to take the derivative of, but in something like a, we could do this another way. It's to the fifth power, so it'd be super long and very tedious, but you could write this out 5 times, multiply them all together. You would end up with a super long polynomial with 16 terms, 15th power, maybe not 16 terms, but you would definitely be to the 15th power, and then you would take the derivative of each term individually, one by one, all the way down. Hey, that's a way to do it, but that is super tedious and long, and that would not be the proper way to do this. Okay, so we're going to use the chain rule that we're learning about today. So the outside function is the power of 5. So we're going to start by doing the power rule. So we're going to multiply by 5. We're going to keep the inside part the same when we do that. And we're going to subtract one from the exponent to complete our power rule. And then we're going to multiply by the derivative of the inside. This is the chain rule part, the g prime of x. So we're going to multiply by derivative of 4x cubed, which is 12x squared, and multiply by the derivative of 3x, which is 3. And we're done. So no long multiplication. We're not going to try to multiply these things together because we'd have to take care of that fourth power, which would be annoying. So we're just going to leave our answer like that. That's great. All right, something like this one, we don't even really have the option to multiply it all out. We could do a little bit of manipulation with this, but the fraction exponent, really the only way to accomplish this is by using the chain rule. Okay, so just like our last problem, we're going to start by multiplying by the exponent, 2/3. We're going to keep the inside part the same when we do that. And then we're going to subtract 1 from the exponent, so it becomes negative 1/3. Then we multiply by the derivative of the inside. Derivative of x to the fourth is 4x cubed. Derivative of 2 is 0. So that's it. All right, we don't want to leave any negative exponents in our final answer, so we're going to move that to the bottom. And so I'm going to end up with a 2 times 4x cubed, which is 8x cubed, divided by 3. and then moving my negative exponent down there. So x to the 4th plus 2 to the 1/3 power. You could rewrite that as a cube root if you prefer, but I like to leave it in exponent form. All right, I'm going to encourage you to try letter C on your own, then unpause the video and see how you did. All right, so this one I think requires a bit of rewriting first. We have a constant on top, so I would not recommend using the quotient rule here. Let's go ahead and just make this a negative exponent, 2x minus 3 to the negative 2 power. All right, then we can do the power rule. We can do it just like we did the last two. So y prime is equal to, multiply by negative 2, I get positive 14. Keep the inside part the same. Subtract 1 from the exponent, so now it's a negative 3. And then multiply by the derivative of the inside. Derivative of 2x is 2. Derivative of 3 is 0. So it's just 2. Don't leave negative exponents in your final answer, so we get 14 times 2 on top, 28, divided by 2x minus 3 to the 3rd power. All right, flip it over to the back and see some other ones. Sorry about that. There we go. All right, so this y prime is actually supposed to be on the front page, so I'm just going to cross that out there. All right, so now we have to take the derivative of this, okay? And this one, unlike the last problem, it's not really going to be helpful to move our denominator up and make it a negative exponent because we already have a function up here. Okay, if this was just a 5, if it was a constant, then absolutely we would do it that way. All right, if you do choose to do a negative exponent, then you're still going to have to use the product rule instead of what I'm going to do, which is using the quotient rule. All right, I don't think there's too big of a trade-off. They're about the same level of difficulty. I think the simplifying is slightly easier doing the quotient rule, which is why I'm choosing to do it that way. All right, so quotient rule is low d high. So low is x squared plus 2 to the 1/3 power. Derivative of the numerator is 5. Minus high d low. So high is 5x. Derivative of the denominator. This is where our chain rule is going to happen. So this is a power, x squared plus 2 to the 1/3. So we start with the power rule. 1/3. Keep the x squared plus 2 the same. Subtract 1 from your exponent. So you get negative 2/3. Then multiply by the derivative of the inside. This is where the chain rule happens. Derivative of x squared plus 2 is 2x. Then all of that gets divided by my denominator, x squared plus 2 to the 1/3 squared. All right, so now we're going to go about simplifying. No negative exponents, no complex fractions. So this part, I'm just going to move the 5 to the front. All right, this thing. The 5x can multiply by the 2x, which multiplies by the 1 on top, and gives me 10x squared. And then this whole negative exponent thing multiplies by the 3, and those are on the bottom. So 3 times x squared plus 2 to the 2/3. And all of that's divided by my big exponent, which is going to use the power to a power rule to multiply those exponents together. So I get 2/3 down there too. All right, so I've taken care of my negative exponent, but I still have a complex fraction. So my next step is to take care of the complex fraction. I'm going to multiply by this denominator here, by 3 times x squared plus 2 to the 2/3 power. And do that on the bottom as well. All right, move over here. Okay, so this is going to distribute all the way over here. 3 times 5 is 15. X squared plus 2 to the 2/3 times x squared plus 2 to the 1/3 is x squared plus 2 to the 1st power. So exponent goes away because they added together and you got a 1. All right, when I distribute to this term, those cancel. So I get minus 10x squared. Then on this denominator, I have my 3 in front, and then x squared plus 2 to the 2/3 times x squared plus 2 to the 2/3 is x squared plus 2 to the 4/3. Simplify a bit, and we're done. So this is 15x squared minus 10x squared is 5x squared. That is plus 30. Then on the bottom, we have our 3 and our x squared plus 2 to the 4/3. And that is as far as we can take it. All right, so chain rule is going to be involved in just any type of derivative you're going to do from now on. Okay, so this is a reminder of all of your trig formulas. Derivative sine is cosine, derivative tangent secant squared, so on. Those are ones you've all learned before, and this is just the chain rule version of it. So notice that we're doing the derivative with respect to x, but inside our function is a u. So you do the derivative like normal, keep the inside part the same, and then you're multiplying by du over dx. This is the chain rule part right here. Right, that is the derivative of the inside of that function. All right, so here's how it works with trig functions. All right, Miss Nancy has a rule here of how to do this. I prefer to think of it as just like keeping with the same thing we did on the front. Derivative of the outside function first, then you multiply by the derivative of the inside. Okay, so derivative of cosine is negative sine. You keep the inside part the same when you do that, and then you multiply by the derivative of the inside, which is 3. And I'm going to rewrite that with the 3 and the negative 1 multiplied together. So negative 3 sine of 3x. All right, try the other two on your own. Unpause the video, see how you did with them. All right, so f is cosine of 5x squared multiplied by 10x. I'm going to put the 10x in front. All right, and g, we get derivative cosecant is negative cosecant of 7x to the 5th, cotangent of 7x to the 5th, multiplied by the derivative of 7x to the 5th, which is 35x to the 4th. I'm going to multiply that to the front, negative 35x to the 4th, cosecant 7x to the 5th, cotangent 7x to the 5th. All right, these are the hardest ones, H and I here. This is going to add another layer. So chain rule is a lot like peeling back an onion. So we start by peeling off the outer layer, then we have the next layer inside and we peel that off, and then sometimes there's more layers on the inside. So we just keep peeling off outer layers until we get to the innermost layer of that. All right, another popular analogy is like a blow pop or a Tootsie Roll. All right, you take off the wrapper, that's your outer layer, then you eat through the candy part, that's your middle layer, and then you get to the chocolate center or the bubblegum center. So that's how the power rule, the chain rule, works. So let's see how to do this here. Now, one thing I will recommend on these two is that if you see a function raised to a power, like cosine to the 4th, a trig function raised to a power like this, rewrite it. So rewrite it as cosine of 5x, all raised to the 4th power. Okay, that's going to allow you to see which function is the outside function easier. Okay, so that's the power of 4 is the outside function. So you start there. You start with the power rule. Okay, so we multiply by 4. We keep the inside the same. We subtract 1 from the exponent. All right, then we multiply by the derivative of the inside. So we're going to multiply by the derivative of cosine, which is negative sine of 5x. All right, but then we have to multiply by the derivative of the inside of that function. And the derivative of 5x is equal to 5. All right, so there's your 3 layers: outer layer, middle layer, inner layer. All right, so I'm going to simplify by multiplying 4 times negative 1 times 5, which is negative 20. Then we have cosine cubed. Just going to rewrite it the traditional way, and then sine of 5x. All right, give letter I a try on your own. Unpause, see how you did. Okay, so rewriting this would be secant of 4x cubed plus 5 squared. So we're going to start with the power rule, same as last time, 2 times secant of 4x cubed plus 5 to the first power, so I'm not going to write 1 there. Multiply by the derivative of secant, which is secant of 4x cubed plus 5, tangent of 4x cubed plus 5. And then that's multiplied by the derivative of the inside there. Derivative of 4x cubed is 12x squared. All right, to simplify, we're going to multiply the 12x squared times the 2, so I get 24x squared. Multiply the secant times the secant, so I get secant squared of 4x cubed plus 5. And then tangent of 4x cubed plus 5. All right, so last couple examples here. We have just a trig function inside a trig function. That shouldn't be too intimidating. We start with the outside function. Derivative of tangent is secant squared. Keep the inside part the same. And then multiply by the derivative of the inside function. Nothing else we can really do with that. So that's going to be our answer. All right, this last one is going to be kind of like an AP style question. How do they force you to do the chain rule? Well, they don't even give you the actual functions. They just give you this function notation and ask you to find the derivative. All right, so we take the derivative of h, and I'm going to go ahead and plug in my 3 for x. Outside function first, f prime. Keep the inside part the same. Multiply by the derivative of the inside, g prime. And I meant to put a 3 in here, so I'm going to go back and put a 3 in right there as well. All right, then we're using the information given to us up here in the problem to find our answer. So I have f prime of g of 3. G of 3 is 4. Multiplied by g prime of 3, which is negative 5. Sorry about the music, but I'm almost done, so I'm going to finish up. All right, then we grab f prime of 4 up here, which is 8. So I end up with 8 times negative 5, which is equal to negative 40. All right, that's it. Hope you enjoyed the video, and I'll see you on the next one.